Alright class, we are back and we want to talk a little bit about the proportions that we have been working on, that we worked on Friday. It was a rather quick review just to see what you remembered um, in terms of doing these proportions. We learned immediately, or recalled I should say immediately, the idea of cross-multiplying when we solve these proportions. So for example, when we had this proportion here, we would cross-multiply right here and get that value became 10x. We would then cross-multiply the other way, 5 times 16, which equaled 80. We have an equal sign here in the middle, so we want to keep that equal sign, and we get 10x equals 80. When we get this equation right here, 10x equals 80, we just wanted to then solve for x. In this case, we would divide by 10 and get an answer of x equals 8. Then when we worked on the back, it became a little bit more difficult. You could still do the 3y times 1 is just 3y. Now, however, this other side of the cross multiplying was a little bit more difficult. We want to multiply 2 by this entire part under the denominator. In the denominator, y plus 1. It's almost like they are having parentheses right there. You want to say 2 times the quantity y plus 1. When we do that, you can now just simplify this part of the equation by distributing. 2y plus 2 still equals 3y. Now you just want to, again, like we have been doing, solve for y. If you subtract 2y from both sides, you get your answer that you need of y equals 2. So that was just a quick review of what we did with cross-multiplying with proportions. This is one of the first properties that we're going to be using. I would suggest getting these into your composition book, both this property and the properties that are going to be coming up here in the next few slides of this flip chart in this video today. Alright, so you remember how to do those. Here's a couple more that you can practice really quickly. If you feel really confident in these and you want to skip ahead, I will encourage you to do that. Only if you feel confident that you can do these. Otherwise, take your time, go through these, pause the video, and make sure that you can get the right answers for all of these. So, and this goes for any problems. If you feel confident that you don't need to do every single example, that's why the videos are nice, you can fast forward. Otherwise, take your time, do what you need to do, and make sure you can answer these problems. So go ahead, try them now, pause the video, and start it up when you're ready to go again. Alright, let's see how you did. This first problem, you get an answer of 16 over 5. Number 6, you get an answer of 12. And number 7, you get an answer of 6. So let's take a look why. As we go through, in this first problem, the cross multiplying is 2 times 8. And in this one, 5 times x. You set them equal to each other, and then you just make it a fraction. 16 over 5 when you divide by 5, and that is in simplest terms. In these, you want to kind of keep them as a fraction. You need to simplify that fraction as best as possible, finding greatest common factors, essentially reducing something from, from 2 over 4, reducing that to 1 over 2, that sort of idea. In number 6, same thing, 3x times 1, pretty easy. 4 times the quantity of x minus 3. Again, think of this as in parentheses if you need to. Distribute that 4 to the x and the 3, and you get a final answer of 12 equals x. Then in this last one, 14 times quantity y minus 3 equals 7y. You need to do a couple steps here. You would get negative 7y equals negative 42. Divide by that negative 7, and you get a final answer of y equals 6. So hopefully that was just a quick, easy remembrance for you. We want to now move on to something new with proportions. This is called the geometric mean. Now we've done regular mean, it's just a normal average, kind of like we were doing with the midpoint formula very recently, where we would take the 2 points, we would add up their values, and divide by 2. We were finding an average of those 2 points. The geometric mean is a little bit different. It's like setting up this proportion right here. If we wanted to find the geometric mean of two numbers, a and b, we would set up this proportion right here. We could then solve the proportion by cross-multiplying, and you'd get x squared equals ab. And then you can then simplify it by taking the square root of both sides, x equals the square root of ab. This idea right here is the idea of the geometric mean, and where we're going to be doing a few problems on this geometric mean, finding a geometric mean of two numbers. So this is another definition that you might want to have in your composition book. I would highly suggest you write it down. So let's take a practice at this geometric mean. The first one you would want to do is, in this problem, finding the geometric mean of 24 and 48. So in this problem, you would say x, which is our geometric mean, and we want to solve for x. X equals the square root of, and you want to multiply the two numbers we want to find. So 24 times 48. When you simplify this, this equals the square root of 1152. Very big number. You now want to try to break it down and see if you can simplify this and get it into its simplest form. Well, right here you already had it broken down into easier forms, 24 times 48. That can just become, 24 can become 2 times 2, which is 4, times 3, which is 12, times 2 again, which is 24. That's the 24 part. If you want to do the 48, 48 is just 24 times 2. So you can do the same thing, 2 times 2, times 3, times 2, times 2 again. This is how it can simplify. You want to get it so that you have everything in simplest terms under that rational. So those two 2's would go together, those would go together, those would go together, and these 3's here would go together. So you would have a final answer. You would have 2 times 2 times 2 times 3 on the outside of the radical, and you still have a square root of 2 on the inside. So your answer in this case should be 24 times the square root of 2. Another way you could have looked at that, if you had gone straight from the beginning, square root of 24 times 48, we just said, is 24 times 2. You can bring that 24 out from the inside, because it's 24 times 24 on the inside equals 24 times the square root of 2. A couple different ways to look at it, but the main idea is you want to set it up with x equals the product of the two numbers that you want to find the geometric mean of, and then simplifying the fraction from there. Or simplifying the radical, I mean, from there. So here are a couple practice problems. Feel free to pause this video, take a look at these problems, try them out on your own, and see how you do. Okay, how do we do? Number 9 here, this answer is 18. Number 10 here, this number is 18 square roots of 3. And yes, you'll notice these problem numbers don't make much sense. It's just here to be able to identify when we go back through. But let's find out, more importantly, how we found these geometric means. In number 9, you wanted to start by saying x, our mean, equals the square root of 12 times 27. You multiply our two numbers together, put it under the square root. That equals the square root of 324 when you multiply that out, and that just simplifies to be an answer of 18. 324 being a perfect square made that problem a little bit easier. Number 10, you weren't so lucky, you had some extra left over. The square root of 18 times 54 is the same as saying the square root of 972. You wanted to try to break that down as much as you could. When you did that, you would get a couple extra factors of 2, a couple factors of 3. You break that down. 972 is going to equal 2 times 2 times 3 times 3 times 3 times 3, one more 3. This pair of 2's came out, this pair of 3's came out, this pair of 3's came out. So you had 2 times 3 times 3, which is 18. Still had a square root of 3 under it. So that's how you would solve those problems. Again, it's just more practice, another way that we're working with radicals and square root and getting simplified answers in the process. Okay, move forward. Here are 3 more properties of these proportions that we want to look at. And the reason we're doing this is because we are going to be setting up proportions here in the next week or so. And in doing these proportions, there are different ways that you can write each proportion. And we need to look over these to make sure that we understand, well, writing a proportion, for example, in this one, if we said A over B equals C over D, somebody else could have also said the same proportion, just flipping it around, moving B and D to the numerator, A and C in the denominator. These proportions are still the exact same. If you were to do cross multiplying, they would all come out the exact same. So that's why this reciprocal property, we're flipping it over the fraction bar, still works. Another way that we want to look at proportions is in this property number 3. A over B, A is to B as C is to D. Then we can also rewrite it if we were to change the location of B and C. In this case, A over C equals B over D. And the same idea, if we were to do the cross products, AD and AD would still be the same. And when you did this one, you would still have B times C. And in this one, you'd have C times B, which is the exact same thing. That's why we can do this proportion that way. And then this other one, this is the trickiest one to look at. If we go from this original proportion, A over B equals C over D. If we were to add to the numerator right here a value of B, that is the same value as we have in the denominator, that means we need to do the same thing to the other side. Except we're not going to add B, we're going to add the same denominator. That is what's going to keep it the same. So in this case, we add B to the left-hand side because B is the denominator. On the right-hand side, we add D because D is the denominator of that part of it. So just to see a couple quick examples looking at them, if 7 is to 10 if 7 over 10 equals x over y, then 10 over 7 equals, all we did was we flipped over the fraction bar. Instead of 7 over 10, we have 10 over 7, so we need to flip this one as well, so the answer is y over x. In this one, we went from 6 over x equals 24 over y. Then 6 over 24 equals what? All we did in that, we brought this 24 from top right down to bottom left. We brought it to the same side. So all we did was switch the location of these two. So we should still have y in the denominator, and we should now have x in the numerator. And this is from property 3, the interchanging property. So our answer is x over y. Alright, 3 and 4, see if you can see them first. In this one, we added x to the left-hand side numerator. X is the denominator on that side. So we need to now add the same amount on the right-hand side. And by same amount, in this case, I mean we need to add the denominator of that right-hand side. So this one should say on the right, 9 plus y over y. And in the last problem, same thing, we added y on the left-hand side, which is what the denominator is. So we need to add 11 on the right-hand side, which is what the denominator is. So we would have 5 plus 11 all over 11, or 16 over 11. Is how that problem would work. Alright, here are a couple of practice problems for you to try on your own. You want to see if you can get the answer for them, and when you are done doing these problems, you can go ahead and restart the video. So pause it, do them, and give them a try. Alright, let's take a look. Number 3 here. The answer, 8 over x equals 3 over y. If we have that, then 8 over 3 equals what? All we did was we moved 3 down here. It switched places with the x. The y should stay the same. This was that third property there, and the answer is x over y. If you look at number 5, right here, x over 6 equals y over 15, then x plus 6 over 6 equals what? In this case, we added 6 to this side. That is what our denominator was over there. So we need to add the right-hand side denominator to the right-hand side numerator. So we need to add 15, y plus 15 over 15. And then, for these other two, you know what? These actually are going to be the first 2 answers on your quiz for this video. So I'm not going to reveal the answer. In this first one, you're going to do the exact same method from number 3. You're going to switch something around. In this one, you need to figure out what you need to add to one side and the other. So give those a try, and those are your first answers, and don't worry if it says your answer is wrong. I look at them all individually to make sure that the answer matches up. So give those a try, type them in to the first quiz. Well, that should be it for this first one. Again, go now and take the quiz. You should have those first 2 answers all ready to go. And make sure that if there are any questions, that you have them asked so that we can answer them first thing on Monday. When we start everything back up, we're going to be moving into the idea of similarity here in the very near future. So, other than that, have a good weekend, or, depending on when you're watching this, hope you had a great weekend and a great St. Patrick's Day. That's all. Have a good one.